Next up, I'd like to welcome to the stage Luis, the co-founder of Gelato, to speak about building your application-specific Ethereum rollup. Take it away, Luis. Thank you.
Hello, everybody. It's beautiful weather in Berlin. Nice to be back in Berlin, where Gelato had its humble beginnings in full node. I guess the Safe team was there back then as well. So yeah, I'm Luis, and I'm the co-founder of Gelato Network. And today I will, for the first time ever in Gelato's history, talk about app-specific rollups and how they relate to Gelato. So stay tuned for the end, because there will be a reveal in this presentation about a new service that we are building at Gelato that we're releasing later this year. That's me, founder of Gelato. If you know Gelato, you probably know it from smart contract automation. We were the first protocol out there doing smart contract automation. Since then, we've been integrated by basically all of the DeFi applications, many others. Everybody has used Gelato automation in some shape or form usually, or our relay systems that have been in production for 2-3 years. Only last week, for example, Connext has used Gelato Relay during their next token airdrop. So we provide this very high throughput, super reliable transaction API that developers have used for account abstraction, like the Safe team, for example, for gasless transactions, or just for multi-chain, reliable, high throughput transaction sending. We also have our Web3 functions. I'm actually going to give a workshop about Web3 functions later today. After this talk, I think half an hour after my talk. So if you are interested in serverless Web3, I will show you how to connect your Lens account to ChatGPT. Yeah, there, it's back. OK, cool. So yeah, that's normally Gelato, but today, none of that. Today I will talk about layer 2s and rollups. And here's the agenda for my talk. And first, I'm going to try to give a very high-level overview of L2s, how they scale Ethereum, why L2s and not sidechains, how do they work, how to choose your data availability layer, rollups versus validiums, how to choose your proving method, optimistic versus ZK rollups, and then how to decide if you even want your own layer 2, because launching your OP stack chain is all the rage right now, right? Like me and my grandma, we all have an OP stack chain suddenly, so why is that actually needed, right? I will also go a bit deeper into ZK rollups, what you need to run them, and then at the end, like I said, I'm going to talk about how you can use Gelato in the future to launch your own rollup, applying the learnings from the previous points. So how does Ethereum scale with layer 2s? And by the way, if you're a technical guy or girl, this talk will be too high level. So it's not as good as an article by Vitalik, or it won't go into technical depth here. But yeah, staying high level, hopefully still useful for a bunch of members here in the audience. So yeah, how Ethereum scales with layer 2s. Essentially, Ethereum started as this super monolithic singleton client blockchain that does everything. Every node in the Ethereum network has to execute every transaction in order to compute the state root. It does all of the data availability, all of the data storage, transaction storage, and then it reaches consensus on the ordering of transactions and blocks, right? So it does all of this, which, I mean, as we know, leads to it not being scalable, super expensive. Ethereum has seen nowhere near mainstream adoption and still was way too expensive for everyone. So rollups came along like Optimism, Arbitrum, Polygon, ZK, EVM, all these guys. And they said, OK, let's look at the stack and let's see what we can separate out, right? So let's take the execution of transactions, the state transition function essentially, and let's run that in a centralized environment for efficiency, high throughput, and whatnot. So-called sequencers, right? Guess what? It still works, right? Like we can do that, and we can still use Ethereum or Celestia for data availability and consensus and settlement. So the key here is that these rollups can move all of the execution of transactions, which is the heavy lifting, the compute, and all of that, off-chain, like technically into a centralized sequencer. Sounds a bit scary, but actually it's fine, because all of the data for these computations and so on still lives on a decentralized network like Ethereum. And now you have things like ZK proofs or fraud proofs that make it so that you can attest and you can feel safe about the computation being done off-chain. You can verify that it was done correctly, very cheaply on the layer 1, thanks to proofs. So wait a second, didn't we already have app chains, like side chains? Like 2017, 16, I was in crypto, and I remember talking to some big pharma companies about their own private whatever blockchains. So we already had this. Why don't side chains work, right? What's so different about layer 2s? And really, it's essentially layer 2s is just a technological development that makes it much cheaper to deploy a secure blockchain without having to sort of reinvent the wheel and repay all of the costs. So with sidechains, security-wise, it's super low because you need a decentralized set of validators, and most sidechains simply don't have it. And yeah, you will never be close to Ethereum-grade security there, at the start at least. And for layer 2s, it's fine because for the important part of data availability and so on, you're just reusing the Ethereum validator set. In terms of security costs, super high for sidechains because you have to essentially create your own token, and then you have to inflate that token, and you have to pay all of these validators, and ideally they're super decentralized, so you have to pay a bunch of them. Whereas for layer 2s, you don't really care because, I mean, the sequencer can technically be sort of centralized, and you just post the data onto L1, which already exists, and that's much cheaper than much cheaper than also running all of the compute on L1, this transaction state function execution, and especially will get much cheaper after dank sharding and so on. Bridging security is, I think, one of the worst aspects of sidechains. Usually, I mean, not all sidechains are the same. There's better and worse, but usually a lot of them literally use just a multi-sig bridge. And even though Safe is amazing, I think we can all agree that maybe a whole ecosystem of a blockchain shouldn't rely on a single safe, right? And yeah, most of these bridges are just multi-sig bridges, or even worse, like we've seen EOA controlling a bridge of a sidechain before, so that's pretty scary. And I mean, Ronin chain, right, got absolutely hacked and obliterated. So yeah, that's not good. Whereas with layer 2s, we have these new cryptographic bridging primitives like ZK bridges. Even with optimistic rollups, at least going into the layer 2 can be done cryptographically fine. Just going back to the L1, as we know, takes a long time. You need for this fraud-proof window to close. But overall, we have new technology available to us that out of protocol suddenly gives a developer amazing secure bridging powers, where before they had to sort of introduce a lot of security risks. And in general, in terms of infra overhead, a sidechain, essentially you're asking many node operators on the world to suddenly run your client. They have huge costs. Whereas with layer 2s, yeah, you can technically run a single sequencer. I know people don't like that so much. Yeah, there's censorship risk. Yeah, there's resiliency problems maybe with that. But overall, like the design permits it. It's okay. And Optimism, Arbitrum today, I think they all have single sequencers, and it does sort of work. The proof is the important part that still needs to happen. So very quickly, how do layer 2s work? I think there's some glitch with the transmission of the slides over here. Someone here who can fix that? Either way, anyways, I'm going to continue, but yeah. How do layer 2s work? Apparently they don't work right now. That can happen as well, so be careful. But essentially, you can think of them as just a smart contract on Ethereum that you submit a bunch of data to from the L2, and periodically you settle the data, the computation that was done on the L2 by posting a new state router. So essentially what you can do now is on the L1 you post all of the data, but you don't do any of the compute. You don't actually execute the smart contracts. You don't actually execute all of this expensive EVM stuff that happens off-chain on the L2 sequencer nodes. And instead, you do all of that off-chain, you get all of the performance improvements, throughput improvements, cost improvements from that, and you just post the data and the final state route on-chain to the L1. And now the magic here that happens is that with that, okay, so the L1 now has the data and they know the state of the L2, but the L1 doesn't know whether the computation was done correctly, and that's really important, right? You want a transfer to be executed correctly. Otherwise, you might have a double spending problem again and so on. And here we have fraud proofs for the optimistic designs. which essentially say, hey, we just keep going, and if someone detects fraud, you can go to the L1 contract, you can play an iterative game, and you can sort of prove that the state root was incorrect that was posted by the L2 node. And then if you prove that, you can get your assets out on the L1, and that's crucial. Like, you can actually exit the L2 rollup if the L2 rollup didn't abide by its own protocol rules. And even cooler with the ZK proofs, you don't need to wait for this optimistic challenge period. There's literally cool, awesome math happening where you can prove that the computation was done correctly on the L2, and you just post this proof on the L1, and sort of immediately you can know whether you want to withdraw your assets from the L2 or not, and whether all of the computation was done correctly. You can verify that with a nice ZK proof. So yeah, that again, what do we gain from this? We can move the execution of transactions off-chain onto technically a single server or like whatever, a cluster, and have huge performance and cost improvements from that, while still securing the user's assets on the layer 1. And that's almost like the best of both worlds. Of course, there's some trade-offs, but it's a pretty cool design. Quickly, how does it look? How does a typical execution flow on a layer 2 look like? And by the way, I think here it's a bit more, especially the later points here, are a bit more specific to ZK rollups. So user would go to Ethereum and lock any assets they want to have available on the L2, like ETH, for example, into the L2's bridge contract on Ethereum. So now these assets are locked on Ethereum, and now on the L2 you can send your transactions to the L2 sequencer via RPCs to Optimism or whatever it is. And then the transaction is finalized on the L2 blockchain, but is not yet finalized on the L1. And that's what we call the trusted state. So at this point, you're trusting that the L2, that it's correct. Then the L2 goes and sends this data onto the data availability layer, like Ethereum or Celestia. And it enables any L2 node to resynchronize from Ethereum and sort of arrive at the virtual state that has all of your L2 transactions in it. And then here, specifically, like in optimistic rollups, nothing happens now, right? Like you're done, and then you just maybe check if the sequencer posts a fraudulent state update. If they do, you challenge it. Right now, I don't think fraud proofs really are alive. Arbitrum has something, Optimism doesn't. So yeah, but ZK rollups already more interesting here, because there's another step where the sequencer and aggregator take a lot of the pending transactions to be verified from the batch that was posted on Ethereum, and they generate a zero-knowledge proof from that. And then they post that proof to Ethereum, and now you have the consolidated state, it's finalized. You can be sure that whatever happened on the L2 has been settled on Ethereum, it's been done correctly, and if not, you can get your assets out immediately on Ethereum against that proof, verifying that some computation was done incorrectly off-chain. So you might have heard of rollups and validiums. And Plasma is basically validiums, but for optimistic rollups. And I will explain to you some of the differences here. Essentially, again, it's about a trade-off spectrum whereby you can pick what you want. Like, do you want low cost but a bit less security, or are you happy with higher costs and more security from Ethereum and layer 1? So in terms of data availability, rollups store all of the data on chain. That's why rollups today are still quite expensive. With a Validium, the data is usually stored off-chain. So this is really like a key differentiator here. The transaction throughput of rollups today is like 200 transactions per second, and for Validium it's roughly 1,000 transactions per second. Transaction cost 5 cents, 1 cent for Validium. The trust mechanism is quite different. With rollups, you have trustless cryptographic security via validity proofs, or crypto-economic security via fraud proofs in the optimistic design. Whereas in Validiums, you really trust that the data availability committee is available to serve the data when you need it, if you want to sort of validate or prove something on the L1. In terms of security, censorship resistance, rollups allows users to force withdrawals and exit the rollup. Validiums sort of do, but only if the data is available. So yeah, there's definitely more censorship risk here. So what are the use cases? Obviously, rollups are better for high security, sort of high value transfers, immutable applications, like scary stuff. Whereas versus Validiums that are a bit more better suited for games, maybe like super high throughput, high frequency things, and low cost use cases. And rollups, we have stacks already. We have the OP stack, we have the Polygon zk AVM, And Validiums, we have Polygon CDK that just dropped, and Arbitrum AnyTrust. So another comparison. Optimistic versus ZK rollups. And yeah, I mean, transaction finality here is a big differentiator. Optimistic rollups take much longer to finalize the state of the L2 on the L1, whereas with ZK rollups, once the proof has been generated, which is quite costly, but still, and posted on L1, you're finalized, you can exit the rollup again. So that means that you can withdraw your funds from a rollup much quicker on a ZK rollup, versus with optimistic rollups, you have to wait for 7 days, unless you use a third-party bridge provider, liquidity provider, which adds some more risk and cost though, right? Throughput, currently optimistic rollups have 200 transactions per second, ZK rollups roughly 100 transactions per second. Optimistic rollups are a bit cheaper at 5 cents per transaction, and yeah. The validation mechanism, that's really the key differentiator. Optimistic designs use fraud proofs. ZK rollups use validity proofs, so ZK proofs. Both are compatible with EVM, but optimistic rollups have attained more equivalence than ZK rollups have thus far. And in terms of security and censorship, optimistic rollups, you have to trust, you have some more trust, versus ZK rollups, once the proof has been generated, or maybe you can even regenerate the proof yourself, it's just cryptography at this point, so yeah, very strong properties here. And frameworks, again, we have Optimism and Arbitrum for optimistic rollups, and for ZK rollups, we have Polygon, ZK EVM, ZK Sync, and Linear. So at first, we had these general L2 mainnets, Optimism, Arbitrum, and whatnot, Polygon, ZK EVM, but now we see sort of a lot of applications launching their own layer 2, right? Like Zora, for example, the NFT network, DYDX on Cosmos, right? So like talking to a lot of our users, we realized that a lot of them on their roadmap have launching their own chain. You probably noticed as well, right? So should you have your own layer 2? Well, if you need low transaction fees, high throughput, fast processing, instant finality, more control over UX, more customizability, maybe KYC, and maybe token utility for your own token, it's probably a good idea to look into it. However, if you need atomic composability, like synchronous smart contract calls, flash loans and whatnot, if you need very frequent liquidity exiting of the system and really good censorship resistance, then you probably need to stay on a layer 1 like Ethereum. So which projects should have their own L2s? This is maybe a bit of a bold take, but perpetual DEXs seem to be quite suited for it. DYDX is doing it, for example. Web3 games, for sure. NFT marketplaces like Zora, we've already seen. Social media platforms like Lens, they should be on their own L2. Enterprise blockchains, ecosystem chains like Base. Payments like Gnosis Pay, they should have their own L2 for payment processing. I think they're working on that. And then vertically integrated DeFi. So if you have a DeFi sort of killer app that does everything, like its own lending, its own swapping, and so on, then you can also have your own L2. Probably an L2 is not the right thing for like yield aggregators like Yearn, because they just need a lot of applications to be like composable with them. Standalone DEXs, probably not due to liquidity fragmentation, but I could see it still happening. Meta DEXs like Arrakis, lending protocols and DEX aggregators probably don't really need their own L2, although you never know. Last but not least, what do I need to run a ZK rollup? Quickly, you basically just need RPC nodes on the L1, L2. You need a ZK prover, aggregator, sequencer, synchronizer, some databases, bridging API, and then you need to deploy the L2 contracts on the L1. And here, really critical though is that's not it. You're not done there. You need a bunch of third-party services like block explorers, TX debugging tools, indexers like the graph, oracles, bridges, relayers, smart contract automation from Gelato, account abstraction, off-chain computation. All these things are available thanks to Gelato and many other third-party sort of middleware providers on layer 1s today, but they won't be available on your layer 2 unless. So that's the big reveal. Today I'm introducing to you Gelato Rollup as a Service, the most advanced Web3 Rollup as a Service platform. So essentially, what we want to provide the Web3 developer with is a platform where they can make the decision if they want to move their application or launch their application on their own rollup, and they have as much configurability to them available as possible so that they can arrive at their most wanted state. Whether that is highly secure, high cost, or super low cost and still some security, completely up to them. And most importantly, we want to endow them with, at day one, all of the services and tooling that they already have on their layer one, because that's, at the end of the day, the stuff that really makes the difference. So yeah, what we can provide you with, if you want to launch your Web3 application on your own chain, is super low cost, like 100x cheaper than Ethereum fees on a Gelato Validium, for example. You can build super fast and scalable apps. You don't have to worry about network congestion anymore because you're on your own chain. You can have like up to hundreds of or thousands of transactions per second. We want to provide you with native account abstraction. We're working with the Safe on that already, with the Safe team, so that you can, from the beginning, sort of onboard your users, like normies maybe that don't want to touch MetaMask and whatnot. You can onboard them without ever them needing to buy crypto or pay for gas and whatnot. So this should be sort of built into your chain. We have really cool tooling and ideas there. And then native access from day one to oracles and smart contract automation, right? Like you can use Gelato on there immediately to automate certain aspects of your protocols. Like many protocols already use us for that. And also oracle data is critical for a lot of applications. So we're already working with Redstone, Pyth, Dia, all these guys, Web3 API on having oracle data be available on your rollup the moment that you launch it. So this is how you can think roughly about the stack, about the rollup stack. So you have your dApp, and there's this middleware layer that's completely hosted and taken care of for you. So that's like RPCs, right, for wallets and your users, indexers to give you like, I don't know, maybe subgraphs and so on, block explorers, on and off ramps, bridge plugins, UIs, test faucets, KYC, all of these things are available on the Gelato platform so that you can sort of, have them available and pick and choose what you need. Underneath, we also provide account abstraction services on there if you want to make use of the great new advancements in UX thanks to account abstraction, oracles, automation, off-chain data, and VRF, for example. And then you can just pick your execution layer. Do you want an OP stack rollup? Do you want a Polygon ZK AVM? We can help you with that decision making. Most importantly, that is available sort of in a one-click manner on the platform for you. And then at the end, you can go deep and choose your data availability layer. Do you want your rollup to settle on Ethereum? That comes with a bunch of costs with it, but has some other nice properties like, you can tap into all of the assets that already live on Ethereum. Or maybe, who knows, maybe we can use Celestia as soon as it's live on mainnet, or data availability committees if you don't care so much about censorship resistance and rather would optimize for lower cost. So we make it super easy for you. We have a bunch of great partners. We're working with the Graph for indexing, Goldsky, oracles, bridges like Connex, Layer 0, block explorers, Etherscan, Dora, all of these guys, we're bringing them on our platform to make them available to you. And also, like obviously, with the Safe team, we're working with Monerium, who have an amazing sort of banking integration with blockchain. So yeah, we want this to really be this one-stop shop for you to launch your own chain that essentially looks similar to Ethereum, but just much cheaper and faster. So the roadmap is we're introducing this Rollup as a Service platform this quarter. And we will already have a ZKVM testnet available for you. We're working with the guys from Polygon there. We will also bring ZK EVM rollups on mainnet later this year, so that you have production-grade ZK rollups with account abstraction in one click. And then we're looking into supporting Validiums in Q1 2024. Again, we're working with Polygon on this to unlock faster and cheaper transactions for gaming use cases and whatnot. And then later in 2024, we actually want to provide fully KYC'd enterprise L2s. That's super important for some enterprises that also want to use blockchain, but they need to be compliant with certain regulations. So we also want to do a lot of integrations there so that they can use our platform. Last but not least, I would like to invite you to come build with us to scale Ethereum, build your own rollup, build whatever you want. like even if you don't want to build your rollup, just work. We can help you with smart contract automation, gasless, account abstraction, all these things. We have 400 plus integrations already in the last 3 years. Pretty much every known project has used Gelato in some shape or form. Bunch of transactions have gone through our system, and we're quite high up in gas users on some of these chains. So thank you very much for coming to my talk and for listening to the Gelato Rollup as a Service reveal. Yeah, make sure to follow me on Twitter. I'm Git pusher everywhere, although I feel like I don't really deserve the name anymore because my Git history is kind of sad in these days, to be honest. But there was a time when I was Git pusher. Maybe I will regain that name. Yeah, and go to gelato.network, and you can find me here. I'm going to be here all day. We have amazing ice cream out there. If you haven't tried it, it's my favorite ice cream in Berlin. So go try that. And also, I'm giving a workshop in half an hour, not about Rollup as a Service, about Gelato Web3 functions, where I will show you how to use Web3 functions to talk to ChatGPT and stream data from ChatGPT to your Lens account, so that ChatGPT posts for you on Lens, essentially. Yeah, I think I have some time for questions.
Yeah. And I think the workshop is at 2 p.m. after lunch.
Oh yeah, 2 p.m. Yes. So 2 p.m. workshop.
Any questions for Luis? Anyone? All right, catch him in the workshop if you have any follow-ups at 2 p.m. Really quickly, just wanted to say also to Gelato, thank you for joining as a partner for SafeCon. Gelato, Fileverse, Gnosis, and Karpatki helped us in making this amazing conference and giving you all the free food and coffee, so please thank them when you see them. But other than that, we're going to break for lunch. We'll be back at 2 for Andreas from Fileverse to give us a talk at 2 p.m. here on main stage, and then as you already mentioned, you'll be in the workshop room giving us some ChatGPT alpha. So thank you.
Thank you.
Thanks, everyone.
Thank you, everybody.